So what you need to do is, in a group of 3 people, okay, you can pick any of your class members to be part of your group, and then you need to discuss about these terms that usually used in GIS.
Yo guys,
Kasha, right timing.
have you guys seen Dr. Uzna's recent online lecture?
Nice. That's from group. The 3 of us. You have an idea? Actually guys, I got an idea.
Assalamualaikum and hi to Prof. Uzni Uchang. Today, my friend and I, with Amizul Hakim and Akasha, gonna explain to you about spatial analysis. Spatial analysis is a process using analytical technique and find relationship, discover pattern, and solve problem with geographical data. It is a process to examine the location, attribute, and relationship of features of spatial data through overlay and analytic technique in order to address a question or gain useful knowledge. Okay, in a short terms, we convert information into data. In spatial analysis, we have GIS. We can do clip, which is we trim and split, and we can select the thing we want. And then we have proximity tools such as buffer. Buffer is a polygon around features of specific distance that can perform to combine overlap buffering. In the short terms, we can get information about length and area. And then we got overlay tools. It means it's a critical in GIS analysis integration of dataset, determine where the different geographic phenomena in coincidence. Okay, it means for example, we got 4 layer, we can combine it and become 1 layer. Okay, then Zul Hakim will continue my presentation.
Hello, my name is Zul Hakim. I will talk about vector analysis. Vector analysis represent real world using point, line, and polygon data. Second is information stored in coordinate. As you can see the picture that I show in the slide, there is 3 types in the vector analysis. The first is point data, line data, and polygon data. Okay, then my next topic is raster analysis. Raster analysis is a process of analyzing spatial information contained in grid datasets. Each cell in a grid contains a value of class, which could be related to soils, land cover, elevation, or another type of data.
Hi Prof. Uznair, it's me Akasha. Now I'm going to continue with point in polygon and line in area. So for point in polygon analysis is a spatial technique that helps us understand how specific points such as crime incidents. So let's say we start with an example involving crime data. By overlaying crime incidents on a map of neighborhoods, we can identify patterns and highlight areas with higher crime rates. Moving on to public transportation, point in polygon analysis allow us to optimize routes and stops, ensuring efficient transit planning and better accessibility for communities. In the realm of business, this analysis is invaluable for assessing retail store locations. By mapping store positions within specific trade areas, we gain insight into strategic market placement and saturation. Line in area analysis focuses on the relationship between linear features like roads, rivers, and the larger geographic areas they traverse. Our first example involves road networks. By employing line in area analysis, we can evaluate how roads traverse and interact with various geographic areas. Moving on to rivers. This analysis allows us to understand how rivers intersect with different land cover types, influencing ecological system and land use planning. In context of drainage, line in area analysis provide insight into how drainage systems such as streams and channels interact with surrounding terrain, impacting flood risk assessment and urban planning. This is an example of map that I created during my internship and mainly use line in area.
Okay then, the last one is area on area. Area on area refers to a spatial analysis or operation where the focus is on the comparison or overlay of two geographic areas. This can involve calculation or assessment related to the extent of overlap, intersection or other spatial relationship between two areas. Okay. This is the analysis overlay between urban and forest. In this analysis, we can precisely determine the areas where humans settlements interact with the forest, generating data needed for sustainable development planning, identifying regions requiring ecosystem conservation, and measuring the human impact on the environment. Alright, that's all from us. Thank you, Prof. Uzne, for hear us all.
Nice.
Okay, let's done.
Good job, boys.
Nice.